Hello everybody. Today we are going to talk about chapter 6, okay, in the section 6.8. Previously, on your single variable calculus, if you are given y equals to f of x and you need to find a local extremum or a relative extremum, then the first thing that you need to find is the critical value of a function. By critical value of a function is the x value, so that your f prime equals to 0, or the x value that your f prime does not exist. Okay, of course, this c, the critical value, must be inside your domain. All right, so if you have this type of critical value, then you can test, okay, whether this critical value gives you a local max or local min, or something else, by using the so-called second derivative test. Okay, the second derivative test says that if your f double prime is positive, then it means that your curve is going upward like this. So by upward, then you see that you got a valley. By a valley, it means that you have a local minimum or the relative minimum. If you have your f double prime at your critical value is less than 0, then it means that the shape of the curve is going downward. Okay, by going downward like this, then it means that you have a hill. By getting a hill, then it means that you have a maximum. Okay, a maximum, relative maximum, or the local maximum. However, this is the drawback of your second derivative. If your f double prime is equals to 0, okay, at the critical value, then you cannot conclude anything. However, if your critical value, it is the one that your f prime does not exist, okay, then you have no choice but using the so-called first derivative test by looking at the side of your f prime. Either you will have a maximum or minimum, or this one will give you nothing. Of course, for this one you can use the first derivative test as well. So the first derivative test always gives you something. Okay, however, in terms of several variable calculus, okay, the one that we are going to consider, we are going to be given a function of two variable first. Okay, so this one is going to emphasize on a two variable function z equals to f of x and y. Of course, we are going to find the so-called critical value again, and we need to have some sort of test to see that whether your critical will give you something or not. Okay, either maximum or minimum, or it can be something else. Okay, all right, so let us go into the details. Okay, this one is the definition of the local maximum. Okay, so a function z equals to f of xy is said to have a relative maximum or local maximum. Okay, so sometimes it's called a local maximum. Okay, at the point x0 y0 if for all point xy in the plane that are sufficiently close to x0 y0, we have x0 y0 is bigger, or is greater than or equals to or the value f of xy. So what you can see, the relative maximum, it means that you are going to see again a hill, but this one, by seeing a hill, is a three-dimensional surface hill, look like this. Okay, so this one is a relative or a local maximum. Okay, and again, as you can remember from your single variable calculus, a relative maximum can happen at several places. Okay, so that's why we just look at all the points that are close to this one. Okay, not the whole domain. Of course, for the relative minimum, okay, if we talk about a minimum, then we are going to see a valley. So at this point, comparing to a neighbor, okay, this one is a minimum. Okay, comparing to the neighbor. So this one is a relative minimum. So we just replace this inequality by the one with less than or equal. Okay, that will be your relative minimum. Okay, and usually if we want to refer to both of them, we are going to use the word relative extremum. Okay, relative extremum. So as we just have the my handwriting figure, this one is like what we just told you. Okay, if you look at it carefully, let's see this one. Okay, the relative maximum. So it means that if you are fixing the point x0 and you cut your surface by this plane, okay, by the plane x equals to 0, so it means that this curve, I mean the red one that we just draw here, okay, is the curve that is the cutting edge of your surface with the plane x equals to 0, right? So it depends on your y alone. This one depends on your y alone, and it is a curve. And by looking at this curve, you see immediately that if you need to find this relative maximum, then you need the slope at this relative maximum to be 0, is it? So it just simply means that your df over, I mean a derivative with respect to y, right? Because right now your x is fixed, your y varies. So this one at this point, okay, let's say that this point is x0, y0, of course. Okay, at this point, this one equals to 0. On the other hand, okay, let me just use the one here. Okay, so if we fixing, okay, if we fix y equals to 0, okay, and then we use this plane, okay, we use the plane y equals to 0 to cut the surface, and then you have a curve like this, okay, as you are cutting edge between the surface and your plane. Then at this point again, okay, if you find the tangent line, your tangent line must be parallel to the xy plane. So it means that the derivative with respect to x, because right now your y is fixed to be y0, okay, at this particular point x0, y0 is also 0. So I mean, to find the relative maximum or a relative minimum, I mean this one you just flip your surface, right, to got your minimum. You have the same idea. Okay, it means that you are going to find the derivative with respect to x and make it equals to 0, and the derivative with respect to y and make it equals to 0 again. Okay, however, as we mentioned before, that the point, okay, that your derivative equals to 0, usually we call a critical point first, and after you got a critical point, then you need to further verify or test whether the critical point that you got is really giving you a maximum or minimum or not. Okay, we get. So this is the rule to find the extremum. Okay, the first rule saying that if your z equals to f of xy, okay, have a relative extremum at the point x0, y0, then, and if, I mean this is very important, okay, if both f sub x and f sub y are defined. So this means that for the several or for the two variable function, okay, we are not going to look at the, you know, the case where your f sub x or f sub y are not defined, okay, or I mean if they are not exist, okay, we don't look at that kind of case. Okay, so this is the most important assumption. Then, I mean, at this point, okay, it is necessary that at this point x0, y0, it must be a solution of the system, okay, of the system f sub x, okay, at the point xy equals to 0 and f sub y at the point xy equals to 0. And by system it means that you need to, the x0 y0 must satisfy both of them, okay, both of them with the n, okay. And the point x0 y0 that you can put it here, x0 y0 x0 y0, where all this partial derivative with respect to x and with respect to y at this particular point equals to 0 is called a critical point of a function f, okay. Of course there will be some critical point, okay, as it is the same thing as your single variable. The critical point can be the point that gives you a local or a relative max, okay. It can give you a relative mean, or it can give you nothing again, okay. It can give you nothing, okay. And by nothing here, okay, it means that it will give you the so-called saddle point, okay, the saddle point. And do you know what the saddle look like? Okay, the saddle look like this, okay. You know that the saddle will be the one that it will put on the horse, okay. So here's the horse and here is the saddle, okay. So by saddle point it means that if you look at this surface in this direction, okay, along the x-axis like this, then you see that, hey, it look like a hill, right? It look like a hill. However, if you look at this direction in terms of y direction, then you see that, hey, it look like a valley, right? So you cannot decide whether it is a hill or a valley. Then this one gives you nothing, which is called the saddle point, okay, the saddle point. And at this saddle point, of course, the either the f sub x and the f sub y will equals to 0 both way, okay. So it will be one of the critical point, but it gives you nothing, not maximum, not minimum, okay. So of course, by this one, then you need to have the test, right? After you finding your critical points, okay, from your f sub x and f sub y equals to 0, okay, you need to have the test, okay. So to have the test, you need to have your critical point first, and you need to find your second derivative. Of course, all your second derivative must be must exist, right, in order for you to find it first. And then you are going to let your f sub xx to be the a, f sub yy to be the b, and f sub xy to be the c, okay. And what you are going to consider is the d equals to ab minus c squared. We just need to recall you a little bit that remember that you used to learn about the so-called Hessian matrix, okay. And the Hessian matrix for your two variable function look like this, remember, okay. And then what you are going to find is the determinant of the Hessian matrix, which is the downward multiply, this one is y downward multiply minus the upward multiply. However, the upward multiply, because usually they are the same, f of yx and f of xy, then it will contribute a square right here, okay. So this one is actually your determinant of the Hessian matrix, okay. But if you don't want to connect it with your Hessian matrix, it's okay, you can just look at the d equals to ab minus c squared. And to me, we are usually we'll look at it as a competition, okay. So look at the a and the b. The a and the b is the second derivative in the same direction, right, either in xx or in yy. But your c, okay, this one, your c square, actually it is the different direction derivative, you see, a different direction derivative. So you are going to compete between the same direction derivative and a different direction derivative. We good? So what we're going to say is that if this one, okay, if the same direction is greater, then you can decide, okay, because I mean for the same direction, it means that either you look at it along the x-axis or you look at it along the y-axis, you see the same thing. You know what I say? If you look at it through the x-axis or through the y-axis, you see the same thing. But not like this one, not like the center point. If you look through the x-axis and through the y-axis, you got a different thing, either a hill or a valley. Are we good? So if this one is bigger, okay, the same direction is bigger, then the behavior of the curve, okay, of the surface will be the same as your one of the direction, okay, because I mean both of them are the same, right? So it will depends on only one of the direction. But if this one wins, okay, if the different direction, one through the x, one through the y win, it means that you see a different thing, okay, either along the x-axis or along the y-axis. So it means that you are getting the center point, okay, the center point. So let's see, this is the conclusion. So if your d, so let me just write down the d again. So your d is actually f sub xx, okay, same direction, f sub yy minus f sub xy square, okay. So the competition between the same direction derivative, I mean second derivative, and the different direction second derivative. So if the same direction wins, okay, if the same direction wins, and one of them, I mean this is your a is f sub xx, okay. If your f sub xx is negative, so what does this mean? So it means that you're having a hill, right? You're having a hill, okay. Just refer to your single variable calculus. So as you have a hill, then it means that a relative maximum occur at the critical value. If again this one still, you see, still your same direction wins, but your f sub xx is positive, so it means that you have the upward shape like this. So as you have the upward shape, then it means that you got a minimum, okay, you got a minimum. However, if your different direction wins, you see this one, because it is the negative, right? So if the one after the negative sign is greater, so it means that the different direction wins, then it means that you don't have the relative extremum at this point, and actually you got a what? Then this point gives you a center point, okay, a center point, which is not maximum, not minimum. However, there's a drawback. One drawback is that if your d equals to 0, then it has no conclusion. You need to draw or some further analysis to design, okay. So of course, I mean usually in this course we are not going to have this kind of case happen, okay. So if this kind of case happen, then you may need to recalculate what you did again, okay, or you may as well ask the instructor whether the setting is wrong or not, okay, right. So for example, let's look at this one. If you need to find the relative extremum, okay, let us use the strategy that we just have, okay. So first, what you need to find is find again a critical point, okay. So by finding f sub x, which is 2x, and make it equals to 0, f sub y, which is 2y, and make it equals to 0, and don't forget that this one connecting by n. So the first one, it means that your x is 0 and your y is 0, so it means that the point that you're looking for is 0, 0, okay. So next you need to do the second derivative test, which is your f sub xx, which is 2, okay, from here it is 2, f sub y which is again here is 2, but then f sub xy, because this one is f sub x already, right? And then you find further the derivative with respect to y, you got 0. And you are going to find f sub xx, the same direction, compete with the second direction, but don't forget that the second direction has 2 terms, okay, but they are the same. So you have a 2 and a 2 and then a 0, so it is positive. So it means that the same direction wins. And then look at one of them, for example f sub xx, it is 2, which is positive. So by positive, it means that you have the upward shape like this. So at this point, the 0 0 gives you a what? Give a relative minimum, okay, value, and the relative minimum value, don't forget that it is f at 0 0, okay, the z value, which is of course in this context it is 0 as well, okay. So I mean, if you like, then you can look at this diagram as a procedure, okay, but it's the same as what we just learned before. So let's look at some more example, okay. For example, this one was your critical, okay, to find the critical first, then f sub x is calculated to be 4x, okay, this one is 0, minus 2y and 5, okay, let it equals to 0. F sub y, it is 2y, then 2x minus 3 equals to 0. So the first one you can rewrite as 4x to y equals to negative 5, and negative 2x plus 2y equals to 3. So you can see that you can, because this is the and, you can get rid of one of them. For example, you can get rid of the 2y by add them up. So you have 2x equals to negative 2. So it means that your x is negative 1. And then as your x equals to negative 1, you can just plug into either one of them to get your y equals to what? 1/2, because it is 3 minus 2 over 2, right? So it is 1/2. So it means that your critical has only single point, which is negative 1 and 1/2. So be careful. I mean, this is your x, this is your y. Sometimes if you get your y first, don't switch it, okay? You need to make it as an order. Second thing that you need to do is to do the test, okay? So you need to find f sub xx, same direction. So here it is a 4. F sub yy, same direction again, you got a 2. But then f sub xy, a different direction, okay? So you have a negative 2, can you see? Okay. And then what you need to do is to do the same direction, compete with the different direction square. So you have 4 and 2 minus, here's another common mistake is that this one is negative, but it is a negative under the square, okay? So actually you have 8 minus 4 again, which is positive. So it means that the same direction wins, and we know that just look at one of them, okay? This one is positive, so it is the upward direction again. So it means that this single critical point gives you a what? Relative minimum and relative minimum value. So I mean, if you want to talk about the value, it is when your x is negative 1, your y is 1/2, okay? Just plug into your original problem right there, okay, to get to your value, okay? So let us go a little bit further, okay? For example, this one. First of all, again, what is the critical points, okay? So you have f sub x, which is 3x squared minus y, and f sub y, which is 3y squared minus x, of course. Okay, so how you can get rid of it? You can say that, hey, this one, your y is 3x squared, and then you can just simply replace your y by 3x squared here. Okay, so it means that you have 3 and y, you see here's the y, and then you still have another square like that, minus x equals to 0. So you have 27, you see, and then x fourth minus x equals to 0, isn't it? And then you can just simply do the factorization. Okay, and it means that your x can be either 0 or your x cubed can be 1 over 27, and it means that your x is simply 1/3. Okay, 1/3. So as you have your x, I mean you have it here that your y is actually 3x squared. So you can use this relation to get your y depends on these two x. Okay, so for example, if x is 0, of course your y is 0. If your x is 1/3, your y is also another 1/3. Okay, and you don't have any crossover because this one, you see, 1x give you 1y. Okay, you cannot cross this x and this y together like this. Okay, this one is not happen. So it means that all the critical points, okay, now you have 0 0 together as a pair, and 1/3 and 1/3 together as a pair, no more. Okay, no more. You cannot switch like 0 and 1/3 or 1/3 and 0. Okay, does not happen. All right, then you are going to do the test. Okay, so f sub xx, which is, I mean, be careful from that one. So you have a 6x, f sub yy, you have a 6y, and f sub xy, which is -1. You see, only this one survive, right? So it means that at 0 0, okay, f sub xx, f sub yy, same direction, compete with a different direction, becomes 0. Is it? Okay, you replace your x by 0, your y by 0, minus -1 square again. This is a common mistake. Okay, this one is negative, but it is inside the square. So you have -1, which is negative. So what does this mean? It means that right now your different direction wins, right? A different direction wins. So it means that this point gives you a what? A saddle point. Okay, a saddle point. Okay, which is not either max or min. Okay, how about at the point 1/3 and 1/3? Okay, so your 6x, I mean f sub xx, f sub yy minus f sub xy square. Okay, you have a 6x 6y minus -1 square. Okay, so you have a 4 minus 1, which is of course positive. So it means that the same direction wins, and one of the same direction, which is at this point as well, it is what? It is 2, which is positive. So it means that it is upward shape like this. So you got a minimum again. So the 1/3 and the 1/3 give you a what? Relative minimum, and a relative minimum value, it is f at 1/3 and 1/3. Okay, and then you just plug into your original problem here. In your exam, okay, you are allowed to use, just plug it in like this, and no need to calculate anything. Okay, you just plug it in like that, so that I know that, hey, you know what the value is and then where to plug in. That's all. Okay, that's good enough. We are not going to calculate anything. Okay. Okay, so this is another example. It's okay. Let's look at further example like this. Okay, this one is actually very easy. What's your f sub x? It is negative 2x, and your f sub y, it is 2y, and as you make it equals to 0, then it means that your xy is of course 0, 0. This one is your critical point. Okay, and then you do the test. So f sub xx, it is negative 2. F sub yy, it is of course 2. F sub xy has nothing survived. So it means that f sub xx, f sub yy, same direction, compete with a different direction. You have negative positive 2 minus 0 square, which is again negative. So it means that your different direction wins. Okay, so it means that this one, the 0, 0, gives you a center point. Okay, and no relative max, no relative min occurs here for this function. Alright. How about this one? Let's give this one as a last example. Okay, so this is your f sub x is a 4x cubed plus 4x minus y cubed, right? And a derivative, actually you have a derivative of the inside with respect to x, so you have a 1, make it equals to 0. F sub y, you have only 4x minus y cubed, and then derivative of the inside, which is negative 1. Okay, so it means that, if you just simplify it by divided by 4, so you have x minus y cubed equals to 0, and for this one you got x minus y cubed also equals to 0. So this one can replace it there, right, because it is the and, so you can just replace this whole thing by 0, because x minus y, we just have that it equals to 0. So it means that actually your x cubed is also 0, so your x is 0. So if your x is 0, you can plug into here to got your y also 0 as well. So it means that the only critical point that you have here is 0, 0. So for the test, you need to find f sub xx. Don't forget that you need to look at it from the one without any factorization or any simplification. Okay, so your f sub xx, it is 12x squared plus another 12x minus y squared, right? You just move it here, and then derivative of the inside, of course, it is 1. Another same direction, f sub yy, you need to look at it from this one, okay, which is negative as well. Okay, so you have a negative 12x minus y squared, and then a derivative of the inside with respect to y, so it is 1. And the last one is f sub xy. Okay, so you can use this one again and find a derivative with respect to y further. So the only term that survives is the second term there. So you have 12x minus y squared and a derivative of the inside with respect to y. So if you look at f sub xx, f sub yy compete with the different direction second derivative at the point 0, 0. Okay, so you replace everything by 0. Okay, this one of course by 0, so everything is gone, minus 0, so it is 0. So it means that you don't really know what it is. So I mean, at this point, okay, we cannot conclude anything about this critical point. Okay, you cannot conclude. If you really want to conclude, then you may need to have some other analysis, or you need to draw this kind of curve to see whether it will give you a max or a min, or still give you nothing. Okay, so we are going to stop this clip right here, and we'll see you next time. Bye bye.